We have microphones now.
There we go.
Okay. Good?
Yeah.
Okay. So when I heard that the topic was the truth, there was a rich set of possible geopolitical topics to cover. But despite that, I wanted to try and figure out, okay, let's talk about something a little less obvious, maybe. What's really exciting right now? What's like the big deal? And there are a lot of hot and trendy topics that are kind of at the peak of their hype cycle, and when they are, they're usually shrouded in bullshit. So let's see maybe if we can take one of those, like deep learning, and pierce through that a little bit and see what's going on. So lots of people are claiming that deep learning will kind of herald in this new age of insanely good AIs. And you know, there have been a lot of really impressive results. It is an interesting technology, but it's actually really fragile sometimes. And so the title of my talk is Deep Learning, 60% of the time it works every time. Because you'd be surprised in how easy it is to break some of these. So disclaimer before I talk about this, I have no idea what I'm doing when it comes to deep learning. I have never built a deep neural network. I don't know what I'm doing in terms of machine learning at all. So I'm stealing a lot of really smart people's hard work for the purposes of making jokes. So what is deep learning in 60 seconds from someone who doesn't know how to do it? So at its core, what we're trying to do is we're trying to figure out how to write a really hard function, okay, like a function that classifies an image. Rather than writing this by hand, we'll just basically hook up a whole bunch of matrix multiplies and use a whole bunch of training examples to figure out what the values in those matrices should be. So here's an example of kind of a network structure. Input comes in the left, classification output is on the right, which is a probability distribution which assigns the highest probabilities to the most likely classes of images. All the connections here are matrix multiplies or convolutions and stuff. So how do we figure out what those matrix values are? It's something called backpropagation, where basically we push the image through the network, we come out the other end, we calculate the error, and then we backpropagate that error to compute a gradient. And once we have a gradient, we can use something called gradient descent and ride that gradient all the way down to some minimum, which minimizes the error from input to output. Awesome. So now we've basically solved for all of these values in our matrices, which are called the weights. It's deep learning in 60 seconds. So after we've done this, what could possibly go wrong? After all, there's like a lot of math on the previous slides, so like it can't be wrong, right? It can't be bad. So I found a couple examples of places where deep networks kind of have done something interesting. So again, stealing people's work. Maria wrote this awesome traffic sign classifier, and it works really well. It scored 30,000 different images of traffic signs with classified them with 95% accuracy. And when she found this image, she was like, hey, let's run it through the classifier and see what it does, right? So this is the probability distribution. The network is really, really certain that it's class 5. Class 5 is an 80-kilometer-an-hour speed limit sign. That is not a stop sign. It's one of the German-like style speed limits as well. So that was kind of fun. There's also been some recent research lately into attacking deep nets adversarially. So remember that when we train, what we do is we move the weights around in those matrices by following the gradient in the direction of increasing our score for the output. Well, we can flip this idea. We can take an image and instead of pushing the weights in the direction of the gradient, push the input pixels in the direction of the gradient. Since the network is responding to gradients, the input image now almost looks exactly the same, but it yields a completely wrong classification. So a 60% confidence panda is now a 90% confidence gibbon. We can do this for any class we like. For example, all of these images here on the left have been slightly perturbed. They've had their gradients on their input pixels pushed slightly in the direction of ostrich. And now they all classify as ostriches on the right. Also note the input image doesn't matter at all, right? I can take noise and push noise in the direction of whatever I want. And all of these images classify with over 99.6% accuracy to what they're stated to be, right? So like, you just push things a little bit in the direction where you want them to go. Snapchat also has some interesting malfunctions with deep learning. So how many of you have used the face swap filter on Snapchat? How many of them have gone poorly? Okay, so here's a couple that Maria and I took. I really don't understand the one where like my eye has been replaced with my face. Those are overlapping, like can't even be the same. And the couch is not even a face. I don't understand. So is deep learning just Silicon Valley's next $7 billion Hindenburg? Probably not. It does have genuine uses, just like a lot of other techniques. But every technique has its flaws and its problems, right? So maybe we shouldn't use it for like everything. So the moral of the story is use the right tool for the job, right? Sometimes the right tool is deep learning. Many times it's not. There's a whole host of techniques, and the more tools you have in your toolbox, the more problems you can solve the right way. So that's it.